Regardless of the time of day for you, I say good morning and how's it going? Hope everyone's doing well. Touching base about last week we spent a lot of time talking about when we could distribute, the rules for distribution. This leads us naturally to think about when we possibly should distribute. Is distribution the right thing to do? Now, could, we said, was really just about ability, right? If you could do something, you are able to. Should was about choice. Should was about making decisions based on the situation that we have, right? Should is often much harder to answer than could, and should is going to be harder to answer with distribution as well. What we want to think about is our goal. So what's the goal when we're distributing? Well, we normally distribute when we're simplifying. And so I think like a safe goal would be something along the lines of this: to simplify an expression in the least confusing way and to avoid making mistakes. To be smart lazy. That's that mathematician term we use sometimes. We say mathematicians are smart lazy, where they do things that work well, but they're like the easiest, most straightforward way to do it. Okay. Now, with that said, let's look at some ideas for when we could distribute and when we should or should not distribute, right? So I think the argument for when we should distribute is just that it makes the terms we're working with simpler. Okay, so if you have an expression with a lot of terms and you distribute and the terms become simpler or easier to work with, well, that's something that maybe you should distribute. One special case note, if you have unlike terms, then you must distribute. And so we don't even have to say should or should not. It's not a choice. You really have to distribute there. Now, for should not distribute, this is a little bit trickier, right? We would say maybe it makes the terms more complicated. It's like the opposite of should, right? Some of the ways it does this, maybe it introduces extra cases of variables, fractions, or decimals. It might make the numbers much larger or smaller, and maybe it adds many extra steps to the process. Now, what do these things mean and what do they look like? Well, we're going to look at some examples to see some cases where we should, and probably more cases where we shouldn't, okay? Let's check them out. Ooh, I love this example. It's one of my favorites of all time. It's so good. 7.35 plus 7.35 plus 7.35, all divided by 7.35. Let's see, if we do this using the steps method, right, then we're going to say, oh, look, there's like parentheses here, and I want to simplify what's in the parentheses, and so I'll do that first. And we get 22.05 over 7.3. We probably used the calculator for the last one. We're definitely going to use a calculator for this one. So now I go and I get my calculator and I start typing things in, and I end up getting 3. Well, that's a nice number to have at the end. Okay. Let's check this out from a distribution standpoint. So if we are distributing here, okay, so we say, oh, look, if we're distributing, then we want to take this 7.35 and divide it into each one of those different terms. And that gives us this, which, oh, actually isn't that bad, because 7.35 divided by 7.35 is 1. Anything divided by itself is 1. So I don't go get my calculator. I just keep, oh, it's just 1 plus 1 plus 1. And it's just 3, right? So notice in this case, by distributing the division, we made all the terms simpler. So this would be a case where distribution makes sense to do. I think it's smart to distribute here. It's smart lazy. You're going to result in less work. Let's look to make a mistake. Let's look at some other cases. Okay, so here we have 3.421 times 2 plus 3 plus 4, or 3 and 421 thousandths times that. Okay, so let's think. If we're going to solve this using steps of operations, then we're gonna start by working inside the parentheses, right? Oh, look, 2 plus 3 plus 4. I think I can do that just in my head. That's 9, right? And now I have 3.421 times 9, and that's not very fun, but I grab my calculator and I type in 3.421 times 9, and we would get 30.789. Okay, so I did 2 additions and 1 multiplication. Okay, cool. If I'm distributing, well, let's see. So now I got to take this 3.421 and distribute it to each one of these values. I use my calculator for all of those things, right? So I type it in a bunch of times, right? We end up getting this, right? 6.842 plus 10.263 plus 13.684. I got to use my calculator to add up all those things. So I'm typing numbers in again over and over again. Oh, I hope I don't type a number wrong, right? But we end up getting the same thing, 30.789. And that's the idea, that this should work both ways. But this way, look at all of the decimals we had to work with over and over again, right? Each one of these times, right, that we distributed here, we had to multiply a whole number by a gross decimal, and then we had to add up all the decimals over and over again. This is what we mean by introducing extra decimals. In this way, we worked with a decimal one time. In this way, we worked with a decimal 5 or 6 times, okay? So this, I would argue, is a clear case for the steps of operations being a better way to approach this. Let's continue. Ooh, so we have 78xy squared times the quantity 19 minus 18. Okay, let's look at this from a steps of operations standpoint. So we have 78xy squared 19 times 18. And I say, oh, look, there's like some parentheses. We'll simplify what's in there first. 19 minus 18. I don't need a calculator for that. That's just 1, right? And 78xy squared times 1 is just 78xy squared. Thank you. That was very straightforward. I didn't really have to do a lot of work for it. Let's look at it from a distribution standpoint. So we say, okay, we have this value on the outside, 78xy squared. We distribute it to our two terms, so times 19 and times 18 there. We end up getting 78xy squared times 19 minus 78xy squared times 18, which is 1,482xy squared minus 1,400. And I'm using my calculator for all these things, and it's annoying, and I might type it in wrong one time, and I get the wrong answer. But if I don't type it in wrong, I get 78xy squared, which is the same thing because both ways work, but which way was easier? This is what we mean when we talk about creating large values or introducing extra variables, right? Look, I have to work with variables over and over again here, and we have these huge numbers, and all that was avoided, it was avoided in the steps of operations side. So now I really think this is a good case for steps of operations. Again, one more, so I'm not dragging it. This is dragging it. It's 0.000012 times 6 minus 5 plus 4 minus 3 plus 2 minus 1. Okay, I'm not going to show you each individual thing working on this because it would just take a long time, but here is the kind of entire process, right? So this is what we're working with. Notice here, we're just sort of doing these operations. So here we do this subtraction, right? And here we do this addition, and here we do this subtraction. I'm not using my calculator for any of these things, right? We're just doing it in our head. 4 minus 1 is 3. And we end up with this expression down here, and I get my calculator out, and I type it in, and it's not the best, but it's fine. I almost didn't write this other side out because it is so gross, but here it is. Okay, so we start by distributing. So I multiply this number times each of these numbers on the inside. So that's 6 times of typing it in to the calculator, right? I can't even draw the 6 arrows, much less want to do the 6 times of typing it in. And now we end up with these 6 things we need to simplify with multiplication, and then we end up with these here, these, right, 6 tiny, tiny numbers that we have to simplify. And now we start simplifying this subtraction and addition and subtraction and addition. Oh, but we're not even done because we're not like, it's not even through there yet, right? And one more subtraction there, and it's just insane. So like, why on earth would you ever simplify here using distribution when you could just use the steps of operations, right? So this is another case. It's a clear winner for steps of operations. This is one of those ones where we added in lots of extra steps, right? because we had to multiply 6 times, and here we only had to multiply 1 time, right? So all that said, if you can distribute, then maybe sometimes you will and maybe sometimes you won't. It is about making a choice, and we can't tell you. It's a choice that you need to make, right? And if you want to say, well, I'm going to always distribute every time because I know how to do it and it works for me, I mean, maybe that's okay. But we don't think it's a good idea because you're more likely to make a mistake, even if it works for you. And you're going to spend longer. And we don't, your time is valuable, right? So that's our goal with this. Should you distribute? It's about the choice we make and the goal we have in mind, okay? And we want to help you make that choice. That's the idea behind this activity. Whew, so much talking. Hope that wasn't too annoying. Hope you're doing well. Peace.